Okay, let's talk about the substitution reactions of ethers with a strong acid, HX. And we're only going to be looking at this two strongest, hydroiodic and hydrobromic. Anytime we do a substitution reaction, what do we need, right? We need a leaving group, okay? And the leaving group in this case is either going to be this methoxide group, okay, or this isopropoxide group. Whether or not it's one or the other, okay, these are just like our alcohols, where both of those, if they come off as just the anion, in other words, if my leaving group is this and I lose this, this of course is a very strong base, right? This right here is a strong base, which would make it what? A horrible leaving group. So we need to turn it into a good leaving group. So just like we saw with the alcohols, our very first order of business is to turn one of these alkoxides into a good leaving group. And so again, very much like the alcohol, the very first step of this chemical reaction is going to be protonation. Okay, so we're going to add a proton to my ether, and I'm going to form this intermediate species here. Okay, which of course has a positive charge. Once I add that positive charge, then I know that I have a good leaving group. Now, this is where things get interesting. So you have to decide what type of leaving group you're going to have. Okay, you have to decide what your leaving group is going to be. And we have to remember that if this is taking place in acid, okay, an aqueous solution is implied, which of course supports an SN1 reaction mechanism. SN1 reaction mechanism results in the formation of a carbocation. And so what we're going to do is we're going to take a look at either one of these two potential leaving groups, okay? And so we literally have two different leaving groups here. And what do I mean by that? Okay, this isopropanol rather, can leave, okay? That would be leaving group number one, or potential leaving group number two would be methanol leaving, okay? And so we're going to look at both of these scenarios and see what happens when I do that, okay? And to kind of make it a little easier, I'm going to throw a CH3 at the end to remind ourselves here that there's a CH3 at the end of that line. Okay, so proposition one, okay? My leaving group is going to leave, and it's going to be isopropanol, which means I'm going to get this. So I'm actually going to form isopropanol plus what? Well, I'm going to form that plus a methyl carbocation. Why? Okay, remind yourselves that the two electrons that are in that bond are always going to go with the leaving group. Okay, so that doesn't look very good, right? That doesn't look great. So the other option, of course, would be to have my methanol as my leaving group. So now I'm going to have this okay. But then what I see is instead of forming a methyl carbocation, okay, I'm going to form the secondary carbocation. So what is the difference between these? I have secondary versus methyl. Okay, we're going to form we're going to form secondary, okay, long before we're going to form methyl. Okay, so to complete this mechanism upstairs, I know that methanol is going to be my leaving group. Okay, so minus methanol, I'm going to form this carbocation here, and then the bromide that I formed in this step can come in and attack. So for this particular reaction, what I end up getting is 2-bromopropane plus methanol as a side product. All right. And so this is assuming one equivalence. Okay. If I do the exact same reaction, okay, if I do the exact same reaction with two equivalents, I'm going to see something else happen. Okay, so everything would be exactly the same, except for if I have an excess of HBr, okay, I'm going to get to this step here. So this reaction mechanism is going to proceed, and I'm going to form the 2-bromopropane. But now, since I do have an excess of HBr, the reaction is now going to proceed via the much slower SN2 pathway, right? So SN2, okay, isn't going to happen unless what? Okay, unless we have all this excess HBr hanging around, which I do. Okay, and so now what I'm going to see is I'm going to see protonation, and then bromide, again, a very slow SN2 reaction is going to attack. Water is going to leave. So minus H2O. And then in this case, I'm going to form bromomethane. And so in an excess of the alcohol, you're going to do what? You're going to take both of these groups, both of these alkyl groups, and you're going to brominate both of those, and you're going to kick off the oxygen and get rid of the water all together. Okay. So on the exam, okay, if I don't say excess, then it's implied that it's one equivalence. If I do give you excess, then of course you make both products. Okay. And keeping in mind, what is ever lurking in the background here? The aqueous solution. So always assume SN1 is going to happen first.